Hello and welcome to lecture series of C and data structures. Today we are going to start with recursions in C. We will be covering what is recursions. We will be understanding what is recursions and why we use recursions. We will be going through with what all are the recursive functions. We will be understanding what is the difference between recursion and iteration. We will be doing some practice exercise, and I'll be giving some exercise or questions to do at your home. Okay, so let's start with what is recursion. So everybody might have solved jigsaw puzzle in your childhood, or you might be doing today also. So how the approach of solving a jigsaw puzzle is? First we try to find out the corner elements, then we try to fix it, and then we try to find out matching elements with those corner elements, and then keep on building the solution. Recursion is very similar to this. Recursion is identifying a smaller problem and solve the smaller problem and bundle the solution of this smaller problem to find the solution of a bigger problem. So how we are solving this jigsaw puzzle is, we are solving a smaller problem by finding out the corner elements, and then we are using that solution and finding out the related elements with the corner elements, and so on, so that we solve a bigger problem, which is a jigsaw puzzle. Recursion is much more similar to that. So for recursion, sometimes it's the best way to solve the problem is by solving a smaller version of exact same problem. Recursion is a technique that solves the problem by solving a smaller problem of same type. So why I'm using it as a smaller problem of same type? Because the problem that we have seen in jigsaw puzzle is attaching the pieces. So that is a problem, that is a small problem, and we identified that jigsaw puzzle can be solved by attaching the pieces. So we first solve how to attach two pieces, and then we solve how to use the attached two pieces to find out next two pieces, and so on. So when you convert this into a program, you will end up in calling functions that call themselves. So functions that call itself are known as recursive functions. So let me repeat it. Functions calling itself is a recursive function. So let's take an example of a recursive function. So here I am giving you a problem. The problem is, write a function to calculate the power of 2. So given you write a function f, and you will be giving a number as an argument, and you need to compute 2 to the power of that number. Okay, in the screen I have shown you the solution also. So we'll be writing this solution, but let's see, I am using this function f. Okay, and here f is again calling itself. So function calling itself is a recursive function. So let's begin with understanding how we have to decide whether we have to write a recursive function or not. So let's break down into a smaller problem. So identifying a smaller problem is a recursive function. So when we say I need to write a function that can give me power of 2. So I have identified that I can get power of 2 by using this approach. 2 into function of n minus 1. In case n is equal to 0, I'll be returning 1. Otherwise, I'll be returning 2 into f of n minus 1. So again, f of n minus 1 will call its f only, and then we'll proceed in a loop kind of manner. So for example, we'll be calculating f of 4. So f of 4 will call 2 into f of 3, which is f of n minus 1. f of 3 will call 2 into f of 2. f of 2 will call 2 into f of 1. f of 1 will calculate 2 into f of 0. f of 0 will return 1. So from this we will be getting, so this piece will, f of 1 will return 2. Then we'll be multiplying 2 with 2 and getting 4. We'll be multiplying 4 with 2 and getting 8. We'll be multiplying 8 with 2 and we'll be getting 16. So this is how we are building our solution. Okay, if you see this call stack, first f of 4 is called, then in f of 4 we are calling f of 3 again and multiplying the result of f of 3 with a 2. Similarly, in f of 3 we are calling f of 2 and multiplying the result of f of 2 with 2, and in f of 2 we are calling f of 1. f of 1 we are calling f of 0. f of 0 will return 1, and then we'll multiply the result of f of 0 with 2. We'll be getting 2, and we'll be multiplying 2 with 2 and we'll be getting 4. 4 multiplied by 2 will be getting 8. 8 multiplied by 2 will be getting 16. The final result will be 16. So let's start with writing code for this. I'll be writing commands. I'll be adding preprocessor directives. Main function, I'll be declaring function f. It will return an integer and take n as an argument. This is our exit condition. Let's take an variable. y equal to 2 into f of n minus 1, and then we'll be returning y here. Let's call this method in main. let me calculate power equal to 4, then power of 2 equal to, I'll be calling f of power I will be printing this in the console. 2 to the power of percentage d is percentage d. So to the power of this is power of 2. Let's save and try to run. So we are getting a result 2 to the power of 4 is 16. Okay. So here what we are doing is we are calling f inside f and calculating the results as we have explained in the PPT. So this is how our function will look like, as I have already explained. So f will be calling itself to solve the problem. So key to identifying the recursive problem is finding the smaller subproblem. That is, if I can calculate this 2 into f of n minus 1, I'll be ultimately getting f of n minus 1 and identifying the exit condition. So when should I exit my function? This is very important. So for example, n is 2 to the power of 0 is always 1. So my exit condition is whenever I reach 0, I should return 1. If we don't find a proper exit condition, it will be very dangerous for a recursive function because it will end up in infinite loop and it will be very difficult to find what is the problem in our code. So these are the two keys for writing the recursive function: identify a subproblem and identify the exit condition. So let's take one more problem, coding for factorial function. So here we'll take a similar approach that we have taken in the previous example. Let's solve a smaller problem, factorial n. So what factorial n, how can I solve factorial n is? So as you know, factorial n can be solved by n into factorial of n minus 1. So if I can solve factorial of n minus 1, I'll be getting factorial n. So we'll be solving this recursively. So we find out a subproblem. And what is our exit condition? So whenever I reach n equal to 0 or n equal to 1, I'll be returning 1. Okay. So as per the previous slide, we have done all the two things: identifying a subproblem and identifying the exit condition. So this is a sample code, that sample function for factorial. If n is less than equal to 1, return 1. This is our exit condition, and this is our subproblem. If n is not greater than 1, then we'll be further going to solve subproblem, which is n into factorial of n minus 1. So let's write code for this. So let's write code for the factorial program. Write factorial of n. Okay, I'll be including stdio.h. I'll be declaring one function. Let me call it f for simplicity, and I'll be calling main method. 0 in this method. We'll be calling f number equal to, say I'll be giving factorial of 3. Factorial equal to f of number, and I'll be printing the result. Factorial of number is factorial. Okay, let's write the function f. Int f, take n, sorry, it will take n. So let's write the exit condition first. If n is less than or equal to 1, then we'll be returning 1. Else return n into n f of n minus 1. Okay, let's save and run it. So here I am getting the result. Factorial of 3 is 6. So what we have done in this program is we are calling function f in itself, like here in this line number 18, we are calling f by giving a value which is n minus 1. So f will continue to call itself unless it reaches some value which is less than or equal to 1. If it reaches a value which is less than or equal to 1, it will return 1. This is our exit condition, and this is our sub problem. So let's see using this diagram how the factorial of 3 was calculated. So factorial of 3 will call factorial of 3, then from 3 I'll be calling factorial of 2, from 2 I'll be calling factorial of 1, then from 1 I'll be calling factorial of 0, and from 0 this will return 1. Okay, I'll be multiplying 1 with 1, this will return 1. I'll be multiplying 1 with 2, this will return 2. I'll be multiplying 2 with 3, this will return 6. So ultimately I'll be getting factorial of 3 is 6. Great. So what is recursion versus iteration? Like, why do we use recursive approach rather than iterative approach, and what are the trade-offs between using recursion and iteration? Let's understand these. So to sum up, yes, recursive functions are sometimes less efficient than iterative functions. Iterative functions are nothing but functions where we call loop instead of a function calling itself. So sometimes recursive functions are less efficient, so we need to consider the time and space complexity while going for a recursive function. So many of the times recursive function leads to memory overflow or stack overflow, but it's not like recursive functions are useless, but we need to take care of our time and space constraint before using a recursive approach. And we should also analyze how much time and how much space will be taken when we are solving our problem with a recursive approach rather than with a iterative approach. So recursive problem can simplify the recursive solution can simplify our solution of problem, often resulting in a shorter and easily understood code. So if you write an iterative code, that code will be a bit lengthy code, and somebody else reading your code will take some more time to understand what is going on in your code. And compared to recursive, if you compare it with recursive code is much more simpler and easy to understand. So it has very limited number of lines, and it is easy to understand what is happening in the function. And very importantly, if recursive function is not written properly, it could result in infinite loop. As I have explained earlier, we should identify the exit condition properly for a recursive function. Otherwise, we will end up in going in an infinite loop, and this will be very difficult to solve. So before deciding on a recursive approach, be sure to have these two in place: identify the subproblem and identifying the exit condition. So let's do some problems. We'll do these problems both in recursive manner and iterative manner. So let's try to solve this problem. Write a function to find sum of digits of a given number using recursion. So first we'll do with a recursive approach, then we'll do with a iterative approach. So let's write the code for this. First I'll be writing it with a recursive manner. Write for sum of digits of given number. So how this will work? If suppose I am given a number, say 3, 2, 4, 5, 3, 4, 5, the result should be 3 plus 4 plus 5, which is equal to 12. Okay, let's write it out. So let me include the stdio.h. and writing function sum and main method let's return 0 in main method. Let's define some number. Okay. Let's call this function sum and print the result. Sum of digits of number is this. So we'll be giving arguments for this number and sum of digits. Let's write it out, this function. Okay, so before writing it out, let's understand what should be our exit condition and how to solve the problem. Okay, So we need to identify two things. One is the exit condition, one is the sub problem in this. So here the sub problem could be n percentage 10 plus sum of n by 10. So here we have y n percentage 10. So let's solve this here. For example, and I will be finding out the remainder of the number when we divide it by 10. So let's take an example of number 3, 4, 5. When we take the remainder of this number, when we divide it by 10, we will be getting 5 plus sum of n by 10. So n by 10 would be 34. Okay, so we'll be taking out 5 and then we'll be solving 34. In the next step we'll be taking out 4 and we'll be we'll be solving 3 and so on. And what should be our exit condition? If n equal to 0, then return 0. So this should be our exit condition. This is our exit condition and this is our sub problem. So let's write a code for this. If n equal to 0, let me take an n less than equal to 0 for safer side. It won't happen, but it's good to have in a safer side. Return 0, else and I'll take remainder. I'll take div. So remainder will be n percentage 10 div will be n by 10, and now we'll be giving our result. So return remainder plus sum of div. Looks correct. Also, what happens if if in this function some improper values are given? So it's better to identify those values and not to execute those values in the function. So if you have seen, I have taken n is less than 0. So in this problem statement we are just considering the positive numbers. So in case somebody has given any negative number, we will be exiting our code with and giving the result as 0. Okay, so it's also a good practice to identify the corner cases, like what all inputs I'll be getting in my function, and handle those corner cases so that in any case your code will not break while you run the code. So let's try to run the code. So here we are getting a result. Sum of digits of 3, 4, 5 is 12. Okay. So what if I give, say, minus of 3, 4, 5? Let me test my code with this. whether am I handling my corner cases or not. So in this case I am returning 0. So always just identify what is your problem statement given. Here the problem statement we are trying to solve is sum of digits of a positive number. In case you want to solve the entire range, you can modify this code and handle all the conditions, but I am telling this just to make sure that you should be aware like what inputs you will be receiving in your function and how to handle those inputs. Okay. So let's write the iterative version of the code. Let's try to solve the same code by iteration. So I'll be using same file. I'll be adding one more method, some in an iteration manner int n. Okay, let me write it out this method. I'll copy it. So let's write it in an iterative manner. Okay, let me define some variables. Let me define some variable called sum. I have already taken sum, so I'll be taking say sum of digits equal to 0 equal to 0. I'm taking dividend equal to 0, initializing all the things. Now while n is greater than 0, sum equal to remainder plus div remainder equal to number percentage 10. This is our remainder equal to number by 10, and we are adding it to sum of digits, and then we'll be returning. So what we have done in this code is we are doing some we have defined three variables. One is sum of digit, one is remainder, one is dividend, one is div, and we'll be looping it till n is greater than 0. If we find n is equal to 0 or less than 0, then we'll be exiting this loop. We'll be calculating remainder and div and adding it to the sum. Okay, let's call it out in my function. I'll call it here only. Instead of sum, I'm calling sum of iterations. Okay, and we have not decremented n equal to n by 10, or we can say n equal to div. Okay, it should be sum of digits plus equal to. Okay, so I made this mistake. It should be this. Sum of digits plus equal to remainder. Let's build and run again. So yes, here we are getting correct result. So this example shows how we can run or we can find solutions using iterative and recursive approach. So this is the recursive function and this is the iterative function. So as you can see, there are very less lines of code in the recursive function, and in iterative function we need to write a lot of lines of code, lot of declarations and all those stuff. So we can take advantage of getting rid of declarations in recursive approach, and looks much cleaner. So it's up to the program logic where if we need a recursive or an iterative approach. So here are some examples which I'll giving you. You can try it out. This would be very helpful in understanding how recursion works. Also, please try it out these exercises at home. These questions are like write a program to find length of a given string using recursion, write a program to find sum of a given integer array using recursion, and write a program to find nth Fibonacci number using recursion. So these are very small problems. All you need to remember is finding out the exit condition and finding out the subproblem. If you do that, recursion would be very easy.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.